We're going to solve problem 169, majority element. So we have to find the majority element in an array. So majority element is the element that appears more than n over 2 times. So meaning that if there are 7 elements, the majority element has to appear at least 4 times. It could obviously be more. But if there are 9, it has to appear 5 times and so on. And if it's 10, it has to appear 6 times, at least. So suppose there are 3 ones and then 2 4s. We do know that 2 is the majority element. How do we know? We literally count them up, right? There are 3 ones and then there are 4 2s. But another way of looking at it is, let's pair each of the numbers, right? And then we are left with 2. So we can say 2 is a majority element. Okay. But so we are pairing them up knowing that knowing all the elements. So what happens if we don't know them? Well, we can loop around the array, and then when we look at the first element, we're gonna say the candidate is a potential majority element, is 1, and then it has appeared once. When we look at the second array, second element, because it's same as the candidate, we increment the counter. And when we look at the third array element, we know that it's equal to candidate, so we increment. So we know that candidate has appeared 3 times. But when we look at the other one, the fourth element, the candidate is not equal to the number we're looking at, so the count actually goes down. And then when we look at the next one, count goes down, and when we look at the next one, count goes down to 0. So essentially what we did was we kind of paired them up so they all cancelled out. And then when we look at the last array, because the count is 0, we're going to change the candidate to 2, and then count has become 1. So we eventually ended up having a majority element. Okay, so what happens if there are more than 2 types of elements? So if there are, say, 3 3, 4 4, 2 2 2 2, and then there should be one more 2, right? Or okay, let me just do it the other way around first. Okay, so we're gonna do it. So we're gonna say candidate is equal to 2 initially, and then count is equal to 1. And after iterating through 5 elements, we have count equals 5. When we look at the next element, count goes down to 4, 3, 2, 1. So we do have the candidate equals 1. But what happens if the 3 3s and 4 4s appear in the front? What's going to happen is pretty interesting, because we're going to have 3 as a candidate initially, and then count is going to be 1. And the second iteration is going to be 2. But because 4 is not a candidate, count will be 1. And then when we look at the next element, count will be 0. So when we get to this element, we have candidate as 1, and then the candidate will be count will be 1, and eventually count will become 5. We had the same sets of numbers, but the count has changed. But it doesn't really matter, because the order of the numbers don't really matter, because when we cancel them out, the majority number will always have a positive count. So essentially, like intuitively speaking, when we have this 3 3 2 2 4 4 initially, they are kind of cancelling them out. But so that's why we have 5 counts. But no matter how they are organized, say it's 3 4 3 2 4 2 3 2 4 2, and then we have one more 2. Even if they cancel out like this, we will always have a positive count of a candidate. So the logic is, so obviously we have to try to use a for loop. The logic is, if, let's just write down the logic really quickly. If count is equal to 0, then current element becomes a candidate, and then we increment the counter. And if it's not equal to 0, if it's not, and if candidate is equal to current element, what do? We just increase the counter, and if not, we decrement the counter. Okay. Up until now I used the for in type, but this time I'll probably use for num in numbers. Int num. Just to switch up a bit. We do need a candidate, obviously. I'm gonna just initialize to 0, and then we need to count equals 0, and then we're gonna loop around. So what we're gonna do is, if count is equal to 0, the current element will be the candidate, and then we are gonna increment the counter. If the counter is not equal to 0, meaning there is a candidate with a positive count, and we have to check if candidate is equal to the current element. So if it's not, it doesn't really matter. If it's not equal to, okay, let's say if it's equal to candidate, it's equal to none. And we're going to increment the counter, and then else we're going to decrement the counter. Let's see, if count is equal to 0, we're going to set the candidate to be the current number, and then we're going to increment the counter. Oh, I said a count. Yeah, I'm kind of used to having a count. If it's not equal, candidate, and if candidate is equal to none, we're going to increment the counter. Otherwise, we're going to decrement the counter. Oh, I forgot to return the value. Return candidate. I'm gonna remove the comments. Okay, let's submit. Good result.